This is the second of a series of videos on the sampling distribution of sample means. And in this video, we're going to address the question, is X bar normally distributed? So remember, there's some random variable X, and we're going to calculate the population mean, mu, by taking a random sample and calculating X bar. And we're interested in what's the sampling distribution of X bar. Well, there's two possibilities. And the first possibility is that the original distribution is normally distributed. So if X is distributed normally, then X bar will be 2. So it's easy enough. And it also works in approximately. If X is approximately normally distributed, then X bar will be approximately distributed normally, or distributed approximately normal. So that's the first possibility. Now the second possibility is this. The second possibility is what if X is not normally distributed? And then we get something called the central limit theorem. And the central limit theorem is incredibly powerful. And what the central limit theorem says is that even if X is not normally distributed, the sample mean will be. So here's the central limit theorem. Draw a simple random sample of size n from any distribution or any population with mean mu and standard deviation sigma. Now notice the key here is we don't know how it's distributed. Then what will happen is X bar will be distributed normally with mean mu and standard deviation sigma over square root of n. Right? This just means distributed normally. If n is large enough. And the key is that there's not necessarily a given number n that's large enough. And some people say that 25 is enough, some people say 28, some people say 30. Probably a good example is to use n as 28 or 30, but remember there's not a given value. This is actually based on a proof using limits, so it's not necessarily a certain number. And that's the central limit theorem. So what that allows us to do is do test with the z-table independently of the distribution, no matter what the distribution is. So that's the central limit theorem. So what we have is that there's two possibilities when we think about whether X bar is normally distributed. First, X is normally distributed. If X is normally distributed, then X bar will be 2. In the second case, if X is not normally distributed, but you draw a random sample of sufficient size, then X bar will be normally distributed.